Hello, good day and welcome to my channel. Now I have a question here. It says, if alpha and beta are the roots of the equation 5x squared plus 3x minus 2 is equal to 0, that we should find the equation whose roots are 1 over beta squared and 1 over alpha squared. Now, let us write down the equation, and that is 5x squared plus 3x minus 2 is equal to 0. Now, the general form of the equation of a quadratic equation can be given as ax squared plus bx plus c is equal to 0. Now, if we compare these two equations, we'll find out that the value of a is equal to 5. The value of b is equal to 3. And the value of c is equal to negative 2. Now, with these values of a, b, and c, we can obtain the sum of roots of this equation and the product of roots of this equation. Now, the sum of roots. Let us look at the sum of roots of this equation. Sum of roots. And since the roots of the equation are alpha and beta, that means the sum of root of the equation should be alpha plus beta. So this is sum of root of the equation, and the sum of root of a quadratic equation is given by the value or the formula negative b over a. So this is how to obtain the sum of roots of an equation when you have the values of b and a. And if we substitute in values, our b is 3, so I say minus 3. That is what we have, minus 3. And then over a is 5. So the sum of roots of this equation is negative 3 over 5. Now, what about the product of the roots of the equation? The product of roots. And that is given as alpha multiplied by beta, which is alpha beta. And so the product of root of a quadratic equation is given by the value c over a. And that will be equal to the value of c is negative 2. So negative 2, and the value of a is 5. So we now have the sum of roots, and we have the product of roots of this given equation. Now we are told to find a new equation whose roots. Now let me write new equation now, because that is what the question is asking us. We also find the new equation whose roots, that is the root of the new equation, is 1 over beta squared from the question and 1 all over alpha squared. That is what the question is asking us. So now, this is a new root of the equation. 1 over beta squared, 1 over alpha squared. So what we are going to do next is to find the sum of roots of this new equation and the product of roots of this new equation. So I'm going to say sum of roots. Sum of roots. That is that will be equal to 1 over beta squared. That is adding the two root. Now this is the root, so we are adding them to get the sum of roots. So sum of roots 1 over beta squared plus 1 over alpha squared. That's the sum of the new root now. Now, what do we do there? We take the LCM of these two, which is multiplying this and this. Multiplying this and that, I have alpha square, beta square, when we multiply these two. So we have alpha square, beta square. So just like we will handle fractions, this alpha square, beta square divided by beta square, I'll be left with alpha square. It is like carrying this beta square and putting it under this. So beta square will cancel beta square and left with alpha square. Then alpha square multiplied by 1 will still give us alpha square. And then the plus that we have there. And then now we look at this. This LCM here divided by alpha square is like alpha square, we cancel alpha square and we'll be left with beta square. So beta square multiplied by 1 up there will give us beta square. So now we just need to rearrange this or simplify this so that we can obtain sum of root as alpha plus beta and also alpha beta. So we just see how we can mingle with this, rearrange this so that we arrive at expressions containing these two terms, sum of root alpha plus beta and alpha beta. Now, an identity for this, when you see the square of two values added together, an identity for it is simply given by alpha plus beta all squared, then minus 2 alpha beta. So this is the identity for this. That means if you expand this and simplify, it's going to take you back to alpha square plus beta square. So the identity for the square of two numbers like this is this. Then all over this alpha square beta square can be expressed as alpha beta all squared. So as you can see, if we expand, because this square will affect what is in all the two terms inside the bracket. So if we expand this, it will take us back to this. So this is alpha square, alpha beta all squared. Now that we have this, we can go ahead and obtain. Don't forget, we are trying to obtain the sum of roots of the new equation. The sum of root is what we are working towards. So if we simplify this, you can say alpha plus beta. So if we check our simplification from the beginning, you can see alpha plus beta, that is the sum of roots, is negative 3 over 5. And the product of roots is negative 2 over 5. So alpha plus beta is negative 3 over 5. And then alpha beta is negative 2 over 5. So we can now come down here and substitute the values for it. So alpha plus beta square will be negative 3 over 5, which is alpha plus beta. Then we are going to square it. Then minus 2 multiplied by alpha beta. Alpha beta is negative 2 over 5. Then all over alpha beta square. Alpha beta is negative 2 over 5. And then we square it. So now if we move on, we are going to obtain this as the square of this will give us 9 over 25. Don't forget, this square will affect the numerator and the denominator, and this negative sign will go. So if I square it, it gives me 9 over 25, 3 square and 9 and 5 square. And then my negative multiplied by negative becomes positive, plus 2 multiplied by 2 is 4, then over the 5 as the denominator. Then everything all over the square of this square will affect the 2, it also affect the 5. So 2 square, don't forget the negative sign will go. 2 square is 4 over the 5 square, which is 25. And then if I move this on further, it will give me the LCM as 25. So the LCM of this 25 and 5 is 25. 25 divided by 25 is 1, multiplied by 9. That will give us 9, plus 25 divided by 5 is 5. 5 multiplied by 4, that will give me 20. Then everything divided by 4 over 25. So I would like us to continue on this other part. So let's continue from here now. So I'm going to say the 9 plus 20 that we have as the numerator, that will give us 29. So I have 29 all over 25, then all divided by 4 over 25. That is 4 over 25. And this will simplify further to give us 29 over 25. Then don't forget, because of this division sign now, when you have a division sign and you change the division sign to multiplication, when we're handling fraction, what we do is to invert the other fraction. So 25 goes up and 4 comes down. So it becomes 25 over 4. And then 25 will cancel 25. And then finally we have 29 over 4 as the sum of roots of the new equation. So the sum is 29 over 4 for the new equation. Now let's go to product of root. We are through with sum of root. Now let's go to product of roots. Now don't forget, the root is 1 over beta square and 1 over alpha square. So multiply them to give us 1 over beta square over 1 over alpha square. So this is the product of the roots. And then 1 multiplied by 1 is 1, to be equal to 1 up. And then alpha square multiplied by beta square, that will be alpha square beta square. And this will be equal to 1 over alpha beta all square. So if we simplify this further, it will give us 1 over alpha beta that we obtained before is negative 2 over 5. You can see it here. Alpha beta, that is negative 2 over 5. So we'll be going there to substitute it in as negative 2 over 5 square. And if we continue here, or let me continue on this side, it will give me 1 all over, don't forget this negative sign will go because we are squaring now. So 2 square, the square will affect the 2 and the 5. 2 square is 4 and 5 square is 25. And then if I continue here, I have is equal to, don't forget this is like the inverse of 4 over 5. Because of the 1, it's like the inverse of 4 over 5. And the inverse of 4 over 5 is 25 over 4. 25 over 4. So this is the product of the root. So that is the product of the root. And don't forget what we obtained as the sum earlier on. We obtained the sum of the root as 29 over 4. You can see it here. Sum of root 29 over 4. So the sum of the root is 29 over 4. And then now, finally, we are going to write down the equation. Don't forget, for a quadratic equation, the word form of expressing it is to say a quadratic equation is x squared minus sum of root x, put x there, then plus product of root, and everything should be equal to 0. So this is how a quadratic equation is expressed. X squared minus the sum of roots x, then plus product of roots, and that is equal to 0. So I'm going to write it as x squared now, x squared minus the sum of roots. This is what to obtain as sum of root, 29 over 4. So 29 over 4, and then x, don't forget to write the x, and then plus the product of roots. The product of root is 25 over 4, and that is 25 all over 4. Now, and don't forget, we should add the equal to 0. That's the equation. And then finally, for us to remove fraction, it is very important that we remove fraction. To remove the fraction from this, we simply multiply by the LCM or the LCD of 4 and 4, any fraction you have in the equation. So 4 and 4, the LCM is simply 4. So we multiply each of the term, both on the right hand side and left hand side, we multiply each term by 4 so that we can clear out the fraction. So x squared multiplied by 4 will give us 4x squared, and then minus 29 over 4 multiplied by 4. The 4 will cancel 4, so we'll be left with 29x, and then plus 25 over 4 multiplied by 4. 4 will also cancel 4, and we are left with 25. And that will be equal to 0 also multiplied by 4 will give us 0. So this is the equation whose roots are 1 over beta square and 1 over alpha square. So this is the final answer to this question. So please don't forget to subscribe to this channel so that you can get more detailed videos like this. Thank you for watching, and see you in the next video.